Good morning, students. This is Galvanic Cell, very important topic in electrochemistry chapter. This is also called electrochemical cell. This is also called voltaic cell. Here the definition is the cell in which chemical energy is converted into electrical energy is called galvanic cell. I just repeat once again, the cell in which chemical energy is converted into electrical energy is called galvanic cell. That means in this cell initially chemical reaction takes place and finally electrolysis takes place. That means after taking chemical reaction then only electrolysis takes place. That is the meaning of definition. This is also called electrochemical cell or voltaic cell. So here this is the construction of galvanic cell. It contains two off cells. This is off cell. So galvanic cell contains two off cells. This is left-handed off cell. This is right-handed off cell. In left-handed off cell should contain anode, not cathode, and right-handed off cell should contain cathode. Left hand off cell should contain anode and right hand off cell should contain cathode. And this is the metallic wire that should be connected externally from anode to cathode. That metallic wire should be connected externally from anode to cathode. And both off cells should contain different electrolytes, not same electrolyte. Both off cells should contain different electrolytes, not same electrolytes. Next, this is salt bridge. It is a U-shaped tube. Salt bridge from here to here. This is salt bridge. It is a U-shaped tube. It contains salts, that is KCl or KNO3 or NH4NO3. All are salts which are present in agar-agar gel. That agar-agar gel is a transparent medium which transfer ions nothing but cations and anions to respective electrodes with equal speed, which transfer ions to respective electrodes with equal speed. That is the role of salt bridge. So this is all about construction of galvanic cell. Now working of galvanic cell. Now I take ZnSO4 electrolyte in left hand off cell and copper sulfate electrolyte in right hand off cell. In ZnSO4 solution I take zinc rod and copper sulfate electrolyte I take copper rod. That means zinc rod acts as anode and copper rod acts as cathode. Why copper acts as cathode and zinc acts as anode? According to electrochemical series, nothing but reactivity series. This is already present in our textbook. That one column is there. According to that one, the SRP nothing but standard reduction potential. The SRP of a metal, the high SRP of metal should be connected as cathode and low SRP of other one should be connected as anode. Suppose I take two metals A and B. Suppose the SRP of A is, let us assume, suppose 0.11 minus 0.11 and the SRP of B is minus 0.15. In these two, which is more value? This is more value compared to this one, because here negative value increases. Minus 0.11, here minus 1.15. If negative value increases, positive value decreases. So this is having more SRP value. This is having less SRP value. This is less SRP value. This is more SRP value. Then it should be, this A should be connected as cathode and B should be connected as anode. So that is the procedure here. So like that, here copper having plus 0.34, it's a potential, and zinc having minus 0.77 SRP values. The SRP of copper is plus 0.34 and the SRP of zinc is minus 0.77. So among them, zinc, this is for copper, this is for zinc. So compared to zinc, copper is having more SLP. So that copper rod should be connected as cathode and zinc rod should be connected as anode. So that is the reason. Next, when these two electrodes are connected through metallic wire externally, then reactions takes place. Those reactions are at anode. This reaction takes place, that is zinc is converted into Zn plus 2 ions by losing 2 electrons. Here at cathode, that means here this reaction takes place, that is Cu plus 2 gains 2 electrons and it becomes copper. So these are the reactions takes place in galvanic cell. That is working of galvanic cell. Next, here by using these reactions we can mention cell notation, that is also called cell representation. Cell notation or cell representation, both are same. While mentioning cell representation, the formula is anode / cathode. That means this double slash indicates salt bridge, that means this one, and anode, that means the reaction which takes place at anode, we should mention that one, and the reaction which takes place at cathode, that should be mentioned here. So anode reaction, this is anodic reaction, this is cathodic reaction. So at anode zinc is converted into Zn plus 2, so you should mention like that, Zn plus 2, not double slash here. That means this indicates that zinc is converted into Zn plus 2 ions. Double slash at cathode, Cu plus 2 ions converted into Cu. You should mention like that, Cu plus 2 slash Cu. This indicates that copper ions converted into copper. Here zinc atom converted into zinc ions. Here copper ions converted into copper. You should mention like that. We should not mention Zn plus 2 slash Zn here Cu slash Cu plus 2. If you mention that like that, then that will be wrong. So at anode, the reaction is, what type of reaction takes place at anode? Zinc is converted into Zn plus 2. At cathode, Cu plus 2 is converted into Cu. Next one. There are some more points. This is zinc is here elemental form. So while writing cell representation, first write elemental form. Elemental form slash, this is what? This is not elemental form, this is ionic form. Elemental form slash ionic form. Double slash, this is here, this is ionic form at cathode. First mention ionic form. Ionic form slash elemental form. So while writing cell representation, we should take these precautions. First one is first elemental form slash ionic form. This is elemental form slash ionic form. That means at anode we should write like this. Double slash, this double slash indicates what? Salt bridge. But at cathode, reverse. First write ionic form slash elemental form. Next. First we should write oxidation part. This is nothing but oxidation. How can we say that this is oxidation? Here loss of electrons takes place at anode. That is why this is oxidation. Here gaining of electrons takes place. That is why this is called reduction. So those are the definitions regarding oxidation and reduction. So while writing cell representation, first we should write oxidation part double slash reduction part. First we should write oxidation part double slash reduction part. So these are the conditions to write cell representation or cell notation. Very simple topic. Next, there are some more points regarding this one. That is, here what happens at anode, zinc converted into Zn plus 2 ions. That means this is electrolyte. In this electrolyte, ZnSO4 is there. That means it contains Zn plus 2 and SO4 minus 2 ions. Here copper sulfate is there. That means it contains Cu plus 2 and SO4 minus 2. So here my question is, the reaction takes place at anode is zinc is converted into Zn plus 2 electrons. That means zinc is converted into Zn plus 2. So here Zn plus 2 ions are there. There is no zinc. Then how zinc is converted into Zn plus 2 at anode? So the point is this electrode involves in reaction. Here in left hand electrode, this metal electrode, that metal electrode is what? Zinc. That zinc rod involves in reaction. That means that zinc rod dissolves in electrolyte. By dissolving that one, then it produces Zn plus 2 ions. Then that rod loses 2 electrons. Next, these 2 electrons moves from this rod to this rod through this wire. I repeat once again, when this zinc rod dissolves in this one, then the electrons lost by zinc rod moves from zinc rod to cathode rod through external wire. That means in galvanic cell, electrons moves from anode to cathode. Very, very important point. In galvanic cell, electrons moves from anode to cathode. Next, when these electrons comes from anode to cathode, then the Cu plus 2 ions, that means these ions present in electrolyte. This is copper electrode. It contains only copper atoms, not ions. But here copper ions are present. When these ions gains these 2 electrons which are coming from anode, then those copper ions gains those 2 electrons and deposited at cathode. That means the amount of copper rod increases. Here zinc rod dissolves. That means amount of zinc rod decreases. But here amount of copper rod increases. I repeat once again, here zinc rod dissolves in Zn-SO4, then this reaction takes place. That means zinc rod dissolves, the amount of zinc reduces. But here copper, this electrolyte involves in reaction. That means this electrolyte contains what? Cu plus 2 ions. Those ions gains electrons which are coming from anode and deposit at cathode. That means copper rod. That means the amount of copper increases. So during galvanic cell reactions, so what happens? The amount of zinc decreases and the amount of copper increases. Amount of zinc decreases and amount of copper increases. Next, one more very, very important point, that is purpose of salt bridge. That means why we should put salt bridge here. What is the role of salt bridge here? I told you already. Here this salt bridge contains salts. Suppose I take NaNO3 salt, NaNO3 salt or KCl salt. In KCl salt, there are so many potassium ions and Cl minus ions are there in this one. Here what happens during construction? Zinc rod dissolves and that means the amount of zinc decreases. That means zinc is converted into Zn plus 2 ion. So here already this electrolyte also contains Zn plus 2 ions and SO4 minus 2 ions. During this reaction, that means the reaction which takes place at anode, because of that reaction, the amount of Zn plus 2 increases compared to SO4 minus 2 ions here. The amount of Zn plus 2 ions increases compared to SO4 minus 2 ions. Because of that, more amount of positive ions are there compared to negative ions. If positive ions or negative ions is more compared to other ions, automatically it does not have stability. If number of positive ions is equal to number of negative ions, then only stability takes place. If their number is more or less compared to other, automatically stability, that solution does not have more stability. So to maintain electrical neutrality, that means to maintain stability, we should take salt bridge. So in this case, what I told you, here positive ions are more compared to negative ions. Here positive ions are more compared to negative ions. So to produce more negative ions here, we should take salt bridge. That means this salt bridge allows more chloride ions to this anode. Then automatically electrical neutrality takes place. Here what happens? What is the reaction takes place here? Cu plus 2 ions is converted into Cu. That means compared to negative ions here this CSO4 contains Cu plus 2 ions and SO4 minus 2 ions. When these Cu plus 2 ions gains electrons from anode, automatically that Cu plus 2 part converted into Cu. Then what is the observation here? Here negative ions are more compared to positive ions. Here, if negative ions are more, automatically this solution becomes unstable. So here we need more positive ion. That means this salt bridge should produce positive ion. So because of that purpose, that means because of electrical neutrality, and to maintain electrical neutrality, we should take salt bridge. That is the purpose of salt bridge. If suppose salt bridge is not there, after some time reaction will be stopped and this cell will be dead. So that is the purpose of salt bridge. And one more purpose is there, one more point, that is here I told you what, when after reaction takes place at anode, electrons flows from anode to cathode, not cathode to anode. Electrons flows from anode to cathode. When electrons flows from anode to cathode, then current flows from cathode to anode. That means after reactions takes place, then current, electricity flows from cathode to anode. Cathode to anode. So that is the purpose. That means if we need study of current, that means there is no disturbance in current, we should take salt bridge. If salt bridge is not there, automatically after some time cell will be dead, automatically electricity will be stopped. So the purpose of salt bridge is 2 points. One is to maintain electrical neutrality, and another one is to flow the study of current, to allow the study of current. That is the purpose of salt bridge. So these are very, very important points regarding galvanic cell, and there are some more points are there. For example, two metals are given like this. One is Ni/Ni plus 2 double slash F minus F2. Suppose the question is like this. That means this is called what? Cell representation. This is called what? Cell representation. Sometimes the question may be like this. What is the reaction takes place at anode if this cell representation is given? So this part is anode part, this part is cathode part. At anode, oxidation takes place. At cathode, reduction takes place. Here what is the question? What is the reaction takes place at anode? So this is the answer. Ni gives rise to Ni plus 2 plus 2 electrons, because in this cell representation this is present in left side. So the left side part is considered as oxidation part, nothing but anode part. At anode, every time oxidation takes place. This is the reaction takes place at anode. Then what is the reaction takes place at cathode? This one, F2 plus 2 electrons gives rise to 2F minus. You should write like this. That means what is the meaning of this one? F2 is converted into F minus. Why we should write like this? Why we should not write like this? F minus plus 2 electrons gives rise to F2. This is wrong, this is right. Why it is right, why it is wrong? Because here this is cathodic part, nothing but reduction part. At a cathode, reduction takes place. Reduction is nothing but gaining of electrons. So this reaction indicates gaining of electrons. Here also this reaction indicates gaining of electrons, but this will be wrong because here negative charge, here negative charge. So we cannot add electrons to negative species. We cannot add electrons to negative species. That is why this will be wrong. And one more point is there, one more reason is there to write like this. Here the charge is how much? Elemental state 0. Here charge is how much? -1. When 0 becomes -1, that means oxidation state increases or decreases here? Here oxidation state decreases. When oxidation state decreases, that will be considered as reduction. In case of oxidation state increases. Suppose if you take this one, here -1, here 0, that means here oxidation state increases from -1 to 0, oxidation state increases. So this will not be reduction reactions, this will be what? Oxidation. So this will be wrong, this will be right. So don't get confused about this one. But while writing cell representation, we should write like this, because I told you already, cell representation means what? Elemental form, first initially in anode part, elemental form / ionic form, and ionic form / elemental form. Because of that purpose we should write like that. But while writing the equation, we should mention like this. This is ionic form / elemental form. And one more point is that this is metal, nickel is metal, but fluorine is non-metals. Fluorine is non-metal. While taking non-metals in galvanic cell, we should mention either platinum or palladium beside non-metals, not in case of metals. I repeat once again, while taking non-metals in galvanic cell, we should mention platinum or palladium beside non-metals. So that is the representation of cell, that is cell representation of galvanic cell. And there are some more points. That is, I take two non-metals, hydrogen and fluorine. The SRP of hydrogen is 0. The SRP of fluorine is plus 3.5. SRP values. So by using these values, we should our target is we should write cell representation. Sometimes the question may be like this. Sometimes SRP values will be given. By using that, we should write cell representation. Sometimes cell representation may be given. We should write equations. The question may be either like this or like this one. So the point is, which among these two, which is less SRP value? Hydrogen is less SRP value. Automatically this part should be connected as anode and this part should be connected as cathode, because here SRP value is more. So while writing cell representation, first what? While writing cell representation, elemental form, ionic form at anode side. So this is anode, this is cathode. So elemental form H2 / H plus. Now double slash. Here cathode part, first ionic form, next elemental form. That means ionic form means F minus, just now we have written already, F minus / F2. Here one more point is that is what just now we discussed it here. This is fluorine is non-metal. Here hydrogen is also non-metal. That means both are non-metals. In case of non-metals, we should mention either platinum or palladium beside this one. Here you should write here only, here platinum. Here you should not write like here. Before this part we should write like this. Here after this one you should write like this. Or you can take either palladium also. Palladium or platinum. Or you can take different, here platinum palladium or platinum palladium. So this is the way to write cell representation in case of non-metals. Next, there are some more points regarding this one. That is, when zinc rod placed in copper sulfate solution, after some time this reaction takes place. When copper rod takes place in ZnSO4 solution, then no reaction takes place. So what is the difference here? Here zinc is put in copper sulfate solution, then what happens? ZnSO4 and copper is formed. But if you take copper in ZnSO4 solution, then no reaction takes place. So what is the point here? Here Compared to copper, zinc is having less SRP. Here I discussed already. The SRP of zinc is minus 0.77. Here the SRP of copper is plus 0.34. So what is the problem here? What is the point here? The metal having less SRP. Listen carefully. The metal having less SRP, which replaces or displaces the metal having more SRP from its solution. This is solution. Copper sulfate, nothing but electrolyte. So the point is what? The metal having less SRP which displaces or replaces the metal which is having more SRP. Here, why this reaction not takes place? Here, copper is having more SRP value. Zinc is having less SRP. So, more SRP metals cannot replace less SRP metals from their solution. That is why this reaction not takes place. So, here the important point is zinc rod cannot be stored in copper sulfate, because when zinc rod is placed in copper sulfate, then that zinc rod loses its nature. That means that zinc rod becomes ZnSO4. But we can store copper rod in ZnSO4 because in that case there is no reaction, because no reaction takes place between copper and ZnSO4. I repeat once again, the metal which is having less SRP, which displaces metal having high SRP from its solution. So the point is, zinc cannot be stored in copper sulfate solution, but copper can be stored in zinc sulfate solution. This is very, very important point. Now next one is electrode potential, that is represented by E. So the definition is, if a metal rod is dipped in its own solution, then the potential exhibited by the metal is called electrode potential. I repeat once again, if a metal rod is dipped in its own solution, then the potential exhibited by the metal is called electrode potential. Here one more definition is there, that is standard electrode potential. Standard electrode potential, that is represented by E naught. So here the definition is, if the potential is measured under standard conditions means 1 atmosphere pressure and 298 Kelvin temperature. That means if the potential is measured at these conditions, then that is called standard electrode potential. So electrode potential means, if a metal rod is dipped in its own solution, then that metal exhibited some potential, that is called electrode potential. If the same metal exhibit potential at these conditions, that will be standard electrode potential. So in galvanic cell, two half cells are there. Here two metals are dipped in its own solution. Here zinc is dipped in ZnSO4 solution and copper is dipped in copper sulfate solution. Both are connected to a metallic wire externally, and here we put salt. Automatically when these metals put in their own solutions, those metals exhibit some potential. Here that potential is called EMF, nothing but electromotive force. For this the formula is E cathode minus E anode. That means potential at cathode minus potential at anode. This is also represented by E RHS minus E LHS, nothing but potential at the right hand side minus potential at the left hand side. And one more formula for this is high SRP minus low SRP. This is the also so you can use any of the formula. High SRP, that means SRP of more SRP value minus less SRP value. So by using these three formula, we can calculate EMF, that means electromotive force of galvanic cell. Next, one more definition is there, that is standard hydrogen electrode, simply SHE, simply it is called and one more name for this is normal hydrogen electrode. Both are same. standard hydrogen electrode or normal hydrogen electrode. Here the point is, simple point is that this is, we take one electrolytic cell and one electrolyte here. Here that electrolyte is either 1m HCl, that means HCl molarity is 1m, or 0.5m H2SO4, that means sulfuric acid molarity is 0.5, and we have to take one electrode. Here that electrode is platinum rod. Around this one we put one glass. Through that glass we pass hydrogen gas. Then after some time that hydrogen gas exhibit potential. That potential is called standard hydrogen electrode potential. So the definition is, when hydrogen gas is passed through a glass tube containing, this is what, platinum rod, glass tube containing platinum rod, which is dipped in 1m HCl or 0.5m H2SO4, then the potential exhibited by the hydrogen gas is called standard hydrogen electrode potential. I repeat once again, when hydrogen gas is passed through a glass tube containing platinum rod which is dipped in 1m HCl or 0.5m H2SO4, then the potential exhibited by the hydrogen gas is called standard hydrogen electrode potential or normal hydrogen electrode potential. So this is the definition of this one. And one more point, we assume standard hydrogen electrode potential is always 0. The standard hydrogen electrode potential is always, we assume, how much? 0. So by using SHE we can calculate SRP of any unknown electrode by connecting galvanic cell or by constructing galvanic cell. I repeat once again, the standard hydrogen electrode is assumed to be 0. So if it is 0, so by using SHE, standard hydrogen electrode, we can calculate potential of any unknown substance, or either it is metal or non-metal, by constructing galvanic cell. That means, suppose this is galvanic cell. So suppose, let us assume this is hydrogen electrode, that means platinum rod is there. Here we don't know, I put X metal. When these two metals connect externally, what happens? Initially electrons flows from anode to cathode, and later electrons flows from cathode to anode. That means, sorry, initially electrons flows from anode to cathode, then current flows from cathode to anode. Current flows from cathode to anode. When current flows from cathode to anode, then we can measure potential, nothing but electrode potential. That means both exhibit some potential. When these metals put in their own solutions, automatically they exhibit some potential. That potential is called electrode potential. So then EMF of this cell is equal to what formula? What is the formula? EC minus EA. Here EC is what? EX. EA is what? Hydrogen. We know the potential of hydrogen is always how much? 0. We have to put EX. Then EMF is already, it is experimental value. Suppose its value is 0.7, then EX equal to how much? 0.7. So then like that we can calculate potential of any unknown substance by using hydrogen, by constructing galvanic cell. I repeat once again. So what is the definition of SHE? When hydrogen gas is passed through a glass tube containing platinum rod which is dipped into 1m HCl or 0.5m H2SO4 solution, then the potential exhibited by the hydrogen gas is called standard hydrogen electrode potential. The standard hydrogen electrode potential is assumed to be how much? 0. When it is 0, we can calculate the potential of any substance. That means either metal electrode or non-metal electrode. The potential of any metal electrode or non-metal electrode by constructing galvanic cell. That means when we construct galvanic cell, we get electromotive force. EMF of the value. Suppose if EMF value we get like this, then automatically that will be the electrode potential of other substance. That's all. Next, there are some more points regarding this one. That is, zinc dissolves in HCl, but copper does not dissolve in HCl. This is the question. Why zinc dissolves in HCl? Why copper does not dissolve in HCl? That is the question. Here, the point is, the potential electrode of hydrogen is how much? 0. But here the potential electrode of zinc is, SRP value of zinc is how much? Minus 0.77. What in before 10 minutes I just discussed about this one. The SRP of the less SRP of substance can displace high SRP. Here minus 0.77 is less compared to hydrogen, so that this zinc can displace hydrogen. That means it can react with this one. But in this case, here SRP value of copper is how much? Plus 3.4. But here SRP of hydrogen is how much? 0. So the high SRP substance cannot replace low SRP substance from its solution. So that is the reason. So the answer is what? Zinc dissolves in HCl because of low SRP of zinc that can replaces hydrogen from its solution. But in case of copper having more SRP value, so it cannot replace hydrogen from its solution. Next one, very important topic, that is Nernst equation. Nernst equation is the equation which gives the relation between electrode potential and concentration of ions at other than standard condition. Actually, this part also included in galvanic cell part, the topic. So the definition is the relation between electrode potential and concentration of ions at other than standard conditions. Standard conditions means what? 1 atmosphere and 298 Kelvin temperature. That will be those are standard conditions. If we measure electrode potential at those conditions, then that will be E0 value. If we want to mention electrode potential other than standard conditions, we cannot use that E0 cell formula. That is nothing but E0 cell is equal to E0 cathode minus E0 anode. We cannot use that formula. In such cases, we should use this formula. So this equation is called Nernst equation. So the formula is here, E equal to E0 cell minus 0.06 by N log of products concentration by reactants, where E is electrode potential, nothing but electromotive force at other than standard conditions. E0 cell means electromotive force or electrode potential at standard conditions, and N is number of electrons involved in reaction. This is concentration of products and this is concentration of reactants. And there are some more formulas are there, that is E is equal to minus 0.06 pH. Sometimes E value may be given, we should find pH. In such case, we should calculate the value by using this formula. And there are one more relation, that is delta G0 equal to minus NF E0 cell. Sometimes E0 may be given, we should find delta G0, or sometimes this may be given, we should find E0 cell. So these are the formulas. Among them, this is very important formula. So where N is number of electrons involved in reaction, P is concentration of products, and R is the concentration of reactants, E is electrode potential at other than standard conditions, E0 cell is electrode potential at standard conditions. That means by using standard conditions, we can calculate electrode potential at other than standard conditions. So that is the Nernst equation. Based on this, one problem is given, that is calculate the EMF of the cell in which the following reaction takes place. So this is the reaction given here. This is the reaction. Given that E0 is given already, so E0 is given, we have to find EMF. So immediately we should strike the formula of Nernst equation, that is we should think of that formula, that is E equal to E0 cell minus 0.06 by N log of products concentration by reactants. So E0 cell is, this is E0 cell minus 0.06 by N value is how much? 2. That means 2 electrons involved in this reaction. How can we say that? Here Ni is converted into Ni plus 2. That means Ni loses 2 electrons. So 2 electrons involved in this reaction. So 2 log of these are the products, Ni plus 2 Ag. and these are reactants Ni and Ag plus. Here Ag and nickel both are in elemental form, both are metals. The concentration of metals are 1. The concentration of metals are how much? 1. That is told already in class 11 chemical equilibrium chapter. And here the ions are mentioned. These ions already concentration is given regarding those ions. Here Ni plus ion concentration is how much? 0.16. And concentration of Ag plus is how much? 0.002. So if you substitute those values, we can calculate the E value. Next, one important topic is there. I just forgot regarding galvanic cell, that is, so this is galvanic cell. That means it contains 2 half cells. These are electrodes. This is electronal wire. This is salt bridge. You should salt bridge. What I told you about this one, initially electrons flows from anode to cathode. After that current flows from cathode to anode. That means after chemical reactions takes place, then only electricity takes place. That means chemical energy is converted into electrical energy. So that is galvanic cell. So what is the point here? Here galvanic cell is a source of electricity. That means if anything is connected to galvanic cell, then that galvanic cell produces electricity to that substance. So galvanic cell is a what? Source of electricity. In case of electrolytic cell, 2 electrodes are there. We should connect it battery. We should pass electricity through battery to these electrodes. Then that electricity enters through electrolyte. Finally, chemical reaction takes place. Here the mechanism is what? Here electrical, when we should pass electricity, then chemical reaction takes place. That means here electrical energy is converted into chemical energy, but here chemical energy is converted into electrical energy. So don't get confused. Here electrical energy is converted into chemical energy. In this case electrical energy is converted into chemical energy, but here chemical energy is converted into electrical energy. Next, here cathode is positive, anode is negative. Here reverse, anode is negative, cathode is positive. These are very important points. Next one, but in both cases oxidation takes place at anode and reduction takes place at cathode. Here anode is positive, cathode is negative. So both reverse. In this case cathode is positive, anode is negative, but here anode is positive, cathode is negative. Though charges are reversed, but the phenomenon takes place in both cases are same. That is, oxidation takes place at anode and reduction takes place at cathode in both cells. Next, very important point during galvanic cell, that is, when we take zinc and copper, then EMF is how much? I told you SRP of zinc is how much? Minus 0.77. SRP of copper is how much? Plus 0.34. So what is the formula? High SRP minus low SRP. So formula so 0.34 minus of minus, that means how much? 1.10 volts. This is what electromotive force or electrode potential of galvanic cell. When zinc and copper is taken in galvanic cell, then EMF of galvanic cell is how much? 1.10 volts. Here the point is, here 3 cases are there. Case 1, if external source, that means if anything is connected here above the galvanic cell, if external source, its potential is 1.1 volt. Then what happens? Here in case of zinc and copper, it is 1.1. But here if external source is more than 1.1, that means more than this one, then this cell cannot give electricity to that substance, because here external source is more voltage. So this galvanic cell cannot produce electricity to that one, but the external source produce electricity to this one. Then what happens? Reverse reaction takes place. Reverse reaction means at cathode this reaction takes place. Zn plus 2 electrons gives rise to Zn. At anode this reaction takes place. That is what Cu gives rise to Cu plus 2 electrons. Because in this case zinc acts as cathode, copper acts as anode. Because this is a non-spontaneous process. Because here external source produces electricity to this one. So because of that reason electrodes changes. So zinc acts as cathode and copper acts as anode. And one more point, electrons flows from cathode to anode. Current flows from anode to cathode. Electrons flows from cathode to anode, but current flows from anode to cathode. Then what happens during this one? What happens? External source produces electricity to this one. That means in galvanic cell charging takes place. These are the points, very very important points. Charging takes place. Suppose case 2. If external source is less than 1.1 volts, if external source is less than 1.1 volt, that means if anything is connected here, then suppose that potential is less than compared to this one, then what happens? This produces electricity to that one. That means discharging takes place, because this galvanic cell produces electricity to that one. That means discharging takes place. Then zinc acts as anode. This is normal reactions. Zinc acts as anode and copper acts as cathode. Next, what other reactions takes place at cathode? Zinc gives rise to at a cathode Cu plus 2 electrons gives rise to Cu. At a anode zinc gives rise to, this is normal reaction. So the point is, if external source is less than 1.1 volt, that means if anything is connected over here, if that potential is less than galvanic cell, then what happens? That galvanic cell produces electricity to that one, then discharging takes place. Discharging takes place. But in previous case charging takes place. Why in previous case charging takes place? In here external source is what? More than 1.11. Here 1.1 volt. When zinc and copper is taken in galvanic cell, its potential is 1.1 volt. But if the external source is having more potential than galvanic cell, then what happens? That external source produces current to galvanic cell, then charging takes place, then these reactions takes place. So this is non-spontaneous process. Why it is called non-spontaneous process? Galvanic cell cannot give electricity to that one, non-spontaneous. But here this is spontaneous process. Because why it is called spontaneous? Because here galvanic cell produces current to that one, that external source. Suppose if external source, case 3, if external source is equal to 1.1, then there is no flow of current. Both cells are in equilibrium. Then there is no flow of current, no current. Both are in equilibrium. So these are the points regarding galvanic cell. This is all about galvanic cell. This is very very important point. This is very bigger topic in this one. If you don't understand this one, you try to watch 2 or 3 times, then only you can understand this one, because this is very important and a very bigger topic. There are so many points regarding this one, so try to watch 2 or 3 times. Thank you.